Hi Algebra students, welcome to video 4. In this video we're learning about vertex form of a quadratic equation and we're learning about quadratic transformations. So in the previous video we learned about standard form of a quadratic, which looks like this: y equals ax squared plus bx plus c. We learned that when we're trying to graph in standard form, we have this formula to find the axis of symmetry, and then to find the vertex you plug that axis of symmetry x value in to your equation to find the y value, and that makes our ordered pair for the vertex. Then you found that you have to create a table of values to find what other points to put in as the points in your parabola. And a lot of you found that it can become pretty time consuming. So the good news for today is I'm teaching a method which makes that process a lot quicker. So first, what we need to know is we are doing transformations on the parent function of a quadratic. So what that means is our most basic function, y equals x squared, with no numbers added or subtracted or multiplied. It's just y equals x squared. And we've done this already. To find the values that we graph, we just plug each of these values into our function to find the y values. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So then when we graph that, we get 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. And I think by now you're all pretty familiar with this shape. You're going to want to get used to that shape from your vertex going over 1, up 1, and over 2, up 4 in both directions. Because what we're doing now is we're doing transformations on this, which means we're basically picking up this parabola, moving it around, and maybe flipping it upside down, stretching and compressing it. So we have what's called vertex form. We do have 3 forms for our quadratics. We've learned standard form. Today we're learning vertex form. So here's what it looks like. Y equals a times x minus h squared plus k. And we've seen something like this actually in quarter 1 of the school year with absolute value, but that was quite a while ago. So the a, h, and k do the same thing that it did with absolute value functions. So the a value in the front does a couple things. If we have a negative number out front, it flips the parabola to be an upside down shape. If you have an a value that's greater than 1, it stretches the parabola, so it becomes more narrow than our original parent function. So it'd be more narrow, it stretches it. And if an a value is less than 1, for example 1/2, it compresses it. So then it would become wider. And I'm actually going to write narrow up here too. So a compression kind of squishes everything down so that the parabola becomes wider. That's what the a value does. The h value, so the number with the x inside of the parentheses, determines how far left or right we need to move our parabola. But the directions it moves is the opposite of what your mind wants it to do. So a positive h value actually moves it left, and a negative h value actually moves it right. And then lastly, this k value, that controls how far up or down we move, and a positive does move it up and a negative moves it down. So vertex form is really, really handy because instead of having a formula to find our vertex, now we can just look right at the equation to find our vertex. The h value is the x-coordinate of the vertex, and the k value is the y value. So you just pull those numbers right from your equation and you have your vertex. To find the axis of symmetry, we know that that's always just the x value of the vertex, so it's just x equals k. So what this means, if I give you a bunch of examples like this, we can draw a sketch of these just using transformations. So we're going to look at each equation, decide how it got transformed, find our new vertex, and do a sketch. This plus 4, remember, a positive means it goes left. So this means we moved our parabola left 4. And then the minus 2 here, it's our k value, means we go down 2. That means our new vertex is -4, 2. So from the origin, we go left 4, down 2, and there's our new vertex, -4. Whoops, this should be a -2 because we went down 2. -4, -2. And then there was no negative in front that told us that we need to stretch or compress, so from there we just draw the same parabola shape as our parent function has. Okay, in the next example, the 1/2, that's our a value, it's less than 1, so it is compressed, we say by a factor of 1/2. What that really just means is our graph is going to be wider. And then the +4 here moves our function, since it's that k value, it moves it up 4. Our function moved up 4, but it didn't move left or right. There was nothing with the x. So that means the x value is still 0, but now we're up 4 for our vertex. So our vertex is at 0, 4. And it still opens up because our a value wasn't negative, but now it's compressed, so it's a little wider than our parent function shape. It's a little squished down. All right, in this next one, we have a negative a value, so that means we have a flip, meaning our parabola should open downwards. And this -2 with the x tells us we need to move the opposite direction of the sign, so we need to move right 2. There's nothing added at the end, so we don't move up or down. This means our vertex is 2, 0, so something like that. And then the negative told us that we need to open downwards. All right, and the last example, the 3 out front tells us we have a vertical stretch by 3, which just means our graph is going to be narrower. The -1 with the x tells us if we move left or right, and since it's negative, we move right 1. And then the -3 tells us we move down 3. So our vertex, we moved right 1 and down 3, so that means our vertex is 1, -3. So 1, -3, something like that. And then we have a vertical stretch, so our parabola should be pretty narrow, or kind of steep. Something like that. In the future, we'll get into finding exact points. For now, we're just doing rough sketches. So now, what if we go in the opposite direction? What if I tell you how a function was transformed? Can you write the equation? Well, we know what form our equation is supposed to have. We're basically filling in values for a, h, or k. So this function, I'm going to leave like a little skeleton. We might have something for a here, we might have something to put for h, and we might have something to put for k. A transformation of 3 units to the left, that goes inside the parentheses with the x. And since it's going left, we need a positive, so x + 3. Transforming 4 units down would be -4. So just a cleaner way to write this would be x + 3 squared -4. Okay, for this next one, if this function was reflected over the x-axis, that means our a value needs to be negative. If it was moved 5 units to the right, that's the number that goes in the parentheses with the x. And since it moved right, it needs to be x - 5. Finally, it moved 2 units up, so that would be a +2 at the end. Okay. On this last example, we have y equals, and then our parabola was reflected over the y-axis, so that tells us we need a negative a value. It was vertically compressed by a factor of 1/3. That still is also our a value. So our a value would be -1/3. It doesn't say it was moved left or right, so we don't have anything to add on to the x in those parentheses. But then it was translated up 8 units, so plus 8. So if I give you the transformations, can you write the equations? All right, the last thing we're going to cover is pretty much what your homework looks like. So if I give you the graph, can you find the matching equation? And your homework will actually be multiple choice, just like this. So what you need to think through is you need to look at the parabola and find your new vertex. And this vertex is the point -5, -5. So the transformation that happened on this function is it moved left 5, it moved down 5, and it still opened up, so it wasn't flipped. So you actually see for these ones, 3 of them have -a values. We don't want that because it opens up. So just actually looking at these negative values, that eliminates choices A, C, and D. But then we do want to make sure, okay, does this make sense? Left 5 means that we have a +5 with the x. Down 5 means we have a -5k value. So perfect, it's choice B. All right, number 2. Here's our new vertex at the point 5, -1. So this graph, you can see it opens downward, so it was flipped. It was moved right 5, and it was moved down 1. So the flip tells us we need a negative, so either choice B or D. So A and C are wrong, because we need that -a value. So then, if we moved right 5, that needs to be the number with the x. And remember, a right means negative, so x -5 right here. And then down 1 is a -1 on the outside. So the answer to this one is choice D. If you want to try a couple on your own, you should pause the video right now and see if you can get the right answer for numbers 3 and 4. Otherwise, I'll just be going through them right now. So number 3, we have our new vertex moved right 6, and it moved down 4. Right 6, down 4. Well, a right 6 tells me I need x -6 squared, so that gives me either option A or option C. So I'm going to cross off B and D. And then moving down 4 should be a -4 at the end. Well, that's looking a lot like option C. And then we don't need a -a value because our graph opens up. So C is right. Okay, last one. This new vertex is right 6, up 4, and it still opens up. So we should not have a -a value. None of these do. Right 6 tells us we should have x -6 squared in our equation. So that looks like options A or D would be good. And then moving up 4, we should have +4. So that is option D. So this last page here is pretty much what your online homework looks like. So you are ready to go do Delta Math homework 4. Good luck.